Okay, so the second part of that is we're going to look into the source code here, the um, that convert the history file to VTF file. Okay, so let's go back to check this again. So history file is a binary file, which means that you cannot read. I open it up, you see all the gibberish symbols that you don't understand because this is binary. This is for computer. It has motor size, but it's not good for to be understood by human being. And then let's check this VTF file. Okay, so VTF file is the one that can be visualized by VMD and also can be read by human being. That you can see, okay, this is atom, radius, mass, charge, name, and I have time, index, I have periodic boundary condition, and 10 by 10 by 10, and which is Cartesian coordinate, that the degree, the angle at each between two coordinates are 90, 90, 90s. All right, and then I will have these the index of the number of the atoms and their XYZ coordinate. All right. So before I even continue, I want to tell you what is the file format I want. Okay, because in the next lecture probably or in the future, I want to write program to analyze my results, and this may not be good for me because the file format is a little bit too informative, and I need to write my program to skip this part of this information, which I don't need. And the only thing I need actually is the coordinates, the XYZ coordinate of each atom, okay, and the box size probably. All right. So I'm going to rewrite this trajectory in a way that I want, which is the XYZ format. So before I continue, I want to show you what is the XYZ format. Okay, so I'm going to, how about just sample.xyz. So this is a sample XYZ format trajectory. All right, so the first line will be the number of the atoms in or particles in one frame. All right, so the program read this integer will go skip the second line. So second line is commentary. All right, the program will not read the second line. You can put anything you want in the second line, and then the follows will read, the program will read 10 lines as here because you have 10 atoms. The first is the character is the name of the atom, and then X, Y, Z coordinates. Okay, and you have 10 lines of this. All right, so this is the format of the XYZ coordinates or files. So if I want to make a sample, that will be like this. If I have, say, 10 atoms, and the second one will be, this is common. All right, and then there'll be like C, say 0, 0, 0, 0, and then I have 10 of them. Okay, 2, 4, 6, 8, 10. All right, and it may have different coordinates, but this is just an example to show you what the XYZ format will be like. Okay, and the trajectory will contain multiple frames of this trajectory. So that'll be like this. Okay, so my trajectory will contain all the frames. This is called one frame. All right, starting with the number of how many atoms in a frame, The second line is a comment, which is not important. And the following is the number of the atoms. The first one is the name of the atom, and then followed by 3 coordinates, which is the position in the Cartesian space. All right. So this is what I want for XYZ coordinates. So let's see whether we can make a program. Okay, this is, I would say, really exciting. And remember, we have this trajectory VTF. Hold on. Traject select VTF.F90 here. Right, this is the program that is used to generate or convert the history file to VTF format. Okay, so let's first see how many lines of this program. Okay, so usually there's program something, program name. This is written by Dr. Michael Seaton in 2018 and 19. And then, which is pretty old and never modified. So, I mean, it could be the good program that there's no bug. And then here comes the declarations. Implicit none, a lot of integer, character, integer, more real number, logical. Okay. And then something, I assume this is the parameter constant. And then, okay, remember we have the minus h, the minus s, minus u, minus something, right? So this could be something we need because we're going to use the minus s, which is sorted. So you have a logical command called sorted, right? This is what we need to remember. Sorted is the case we want to remember. And then some program output, right? This is the program output. Okay. And then what else? A lot of logical control. So it's starting read the history files. So I assume this is the reading part of the history file. It could be very complicated because it's reading binary information. Okay. So see, this is all the read, but we don't change this part. Okay. We are not going to change the read part. We're going to change the write part. All right. Because we want to write into a different format. We don't want to mess with this part. Okay, so just skip. These could be important because remember in the end, for the XYZ format, we want to write the total number of atoms, total number of particle. And I'll be careful about this because we don't know actually what's the variable used here. Because remember, we have 3,000 particle and we have 1,500 W and 1,500 O, right? So what we want here in the new file is when we select the 1,500 O, we want this number to be this instead of 3,000. So I assume there will be a variable for total number of bits and the variable for the select number of bits, right? So I assume this is the one we should be looking for, but I'm not sure. We can test that by the program later. Okay. So what's that? I don't know. Okay, this could be also important because we're going to output the species, right? We're going to output the name of the species. So LTP, I don't know what's for, but LTP is the one related to species. All right, related to species, and we're just going to find a name. Okay, this could be N species. Okay, this could be species number, the index. Like remember we have 1 and 2 for W and O, so that could be it. But we are looking for name. We're looking for name of the species. So keep going. That goes to bound. Okay, because we haven't deal with the chain molecule. That'll be more complicated, but we can save it later. So okay, see. So total number of the B in system is number of B. Total number of non-bound B is this. Okay, that's important information. So number of beads is the solvent beads, I assume. It's a solvent beads. NU beads is for non-bound beads. Okay, let's continue. So this is some output we see in the VTF file, but we don't need that right now. We're going to just keep continue. Okay, so this information we see when we run the traject select F90, right? So several cases. See, this is already huge enough that, see, it's only 40%. We for this program we already a little bit lost, right? But it's okay, just keep continue. Oh, you have another thing, B number, read B number, pre-molecule number to include in the file, B number. So it could be non-B or B number, I'm not sure. It could be number B or B number. I don't know, I'm not sure which one is correct. We just write both of them. B number beats. Okay, B number is 0, and if that happens, that plus 1. See, this actually select, the B. Okay, this is a counter starting from 0, and when situation happen, then it will plus 1, and it will go from 1 to number of beats. So I assume number of beats is all beats we have. I'm pretty sure of that. So we should use B number, all right? But that's save it for later. Okay, you see, this is very considerate. They have common for each block of the program, okay? Selecting bits to include determining printable and indices. Remove bounds involving the particle that is not included, okay? Get the number of trajectory frame to include in the trajectory file. Okay, this we don't need to change. We just keep it the same. Write output file, all right? Write output file. So this is the one we're looking for. So we're looking for VTF file. Okay, we don't want any other stuff. And then, okay, so this is the VTF file. You open a channel called NRT out. This is so important because in the end, we're going to write something called XYZ file, which get information, selected information from VTF file. So we're going to parallel, we just copy everything we have for NRT out again, and then only output the information we need, okay? B number is 0. Wait, hold on. B number, okay, should really be the B number. Oh, this is important. See, you see, this is the output of information for the screen, and this is the corresponding variable. So we know that the last one is the name. Variable for name is the name species, NAMSP. I have a paper and pencil by me. I'm going to write this down. You should do the same as NAMSPE. And remember, we have the LTP, and probably we need to put the LTP inside here, all right? We don't need the mass and charge. This, we don't need them. Number of B, okay, this should be most one of them, I'm not sure. Remember this NRT out. If that is true, then write all this, else write all that. And we don't need this part. We only need the coordinates. Velocity, position, velocities. So position is the one we're looking for. Dimension X, dimension Y, dimension. This could be the box size. Okay, this should be the box size. NRT out, if something happened, then I'll write the box size, right? Remember we have PBC, the box size, 3 box sizes. So dimension X, Y, and Z are the box size, all right? Okay, see, if volume change or the first step, then I will output the box size. So you won't output the box size if it is the same from the previous frame, which we don't want this situation. We want the box size printed in the second line of our XYZ format files, all right? Okay, if sorted, remember if sorted, this is minus S, this is what we're looking for, then I equals 1 to m bits, I'm going to write this should be the number of the atoms, and this should be read data 1, 2, 3 should be the coordinates. I'm assuming they are centered in 0, 0, 0. So that's why they are adding a half box size to make it from 0 to box size. All right. To make sure there's no minus value, negative value. Okay. So what else do we have? Close NRT out. So the program stop here. The rest will be function and subroutine, I assume. Right. These we also don't want to mess with that because these are all important functions. We don't want to modify the function, but only the program, the writing itself. All right. So again, here is a go through with this the program, and we're going to make a copy and modify it later. All right.